everyone. So for today's lesson, we will be discussing a lesson about determine whether a system is in static equilibrium or not. So first of all, do you know what is static equilibrium? Anyone? Okay. So today we'll be discussing about it. So what is static equilibrium? So what is static equilibrium? Static equilibrium means an object is completely at rest. It's not moving forward, backward, or rotating. This happens when all the forces and torques acting on it balance each other out. So, static equilibrium means it's a thing that doesn't be moving or completely at rest, not rotating, not moving forward, just completely at rest. But if you intentionally touch it or move it, it will be considered not a static equilibrium. So that is static equilibrium. Next. So how to determine static equilibrium? Do you have any idea? Okay. How to determine static equilibrium? To check if a system is in static equilibrium, follow these two conditions. We have two conditions to follow to determine it. First, check the forces. The sum of all the forces must equal zero. No net push or pull. The object does not move in a straight line. So, to determine the static equilibrium, you should always check the forces because the forces must be equal to zero to balance it. And the second is check the torques. The sum of all the torques or rotating must equal zero. Like I said minutes ago or seconds ago, no net twist or rotation. The object does not spin or tip over. If both are true, the object or system is in static equilibrium. So like I said seconds ago, that the force and torques must be equal to zero to balance the amount of it or the forces or torques of it to determine the static equilibrium. So next, these are the wait, these are the formula. These are the formula of static equilibriums. So these are all the static equilibrium formulas. This the first is Fx equals to 0. The sum of all the forces in the horizontal or x direction must be 0. So, according to static equilibrium, the main point of it is the object must be all equal to 0. The forces and the torques of it must equally be 0. And Fy equals to 0, the sum of all the forces and the vertical or y direction must be 0. So it's all 0. And third is m equals to 0, the sum of all the torques or rotational forces about any chosen pivot point must be 0. So eventually it's all 0 talaga. So next, let's move on to static equilibrium examples. First example is a 15 Newton picture frame hanging from a nail. Two ropes support the picture frame, each making an angle of 30 degrees with the horizontal. What is the tension in each rope? So the question is, what is the tension in each rope? So we have two ropes that support the picture. So we are adding two. And the problem is t, so we're gonna add the t. This is the solution. And then sine 30 degree so that the equivalent will be 50 Newton. So the problem is tension. So we'll be transfer the tension in here, so it cannot be cancelled or like that. So 15 Newton divided by 2 sine 30 degree, and it's equivalent to tension equals 50 Newton. Like I said before, it is static equilibrium because the tension is, or the force or forces doesn't being changed, or it's just completely at rest, because the result of it, it's not been moving, it's just the two rope supports it, and it's completely normal because it doesn't being move. So let's proceed to another example. So this, it's also another example of static equilibrium. A 100 kilogram beam supported by two pillars. A beam of length 4 meters is supported by two pillars, one at each end. The beam weighs 100 kilogram. What is the force exerted by each pillar? So the problem is, it's asking the beam weight, what is the forces exerted by each pillar. So the problem is, it's asking what is the force exerted in each pillar. So the solution, F1 plus F2 equals 100 kilogram times 9.8 meter per second. The meter per second, the 9.8 meter per second is equal to gravity. That's what's asking. Because or the force is the problem is asking a force. So that's why we're adding this force. Yeah, this force, or this gravity force. And then we're gonna put aside here the F1 plus F2. It will gonna be F1 equals F2, and equals 100 kilogram times 9.8 meter per second divided by 2. So F1 equals F2 equals 490 Newton. Each pillar exerts a force of 490 Newton. So, conclusion. This is an example of static equilibrium because the net of force acting on the beam is zero, and it is at rest. The upward forces, pillar forces, balance the downward force or weight, resulting in no acceleration. So that's it. Another example, and this time, this example is not a static equilibrium. So this is the example of not static equilibrium. So example of it, a 1,500 kilogram car accelerating at 2 meter per second squared. A car is moving with a constant acceleration. What is the net force acting on it? So did you notice that not static equilibrium example is mentioning acceleration, or the more of the word accelerating, because in the static equilibrium doesn't mention any acceleration, or must be no acceleration happen because the tension is just completely at rest, or forces like torques, all of them. And in solution, F equals ma. F equals 1,500 kilogram times 2 meter per second is equivalent to 3,000 Newton. The net force is acting on the car is 3,000 Newton. This is not an example of static equilibrium because the net force acting on the car is not zero. Like it changed because of the acceleration. Resulting in acceleration, the car's velocity is changing, indicating that the forces are not balanced. Like I said before, static equilibrium must be balanced or equally to zero of all the torques and um, torques or forces that happen. So next, this is another example of not static equilibrium. I hope you guys would understand my explanation. Yeah. And then, okay, let's read it. A ball thrown upwards with an initial velocity of 20 meter per second. What is the acceleration of the ball? Oh, another example, and it's mentioned again a word acceleration. So solution. The ball is under the sole influence of gravity. So its acceleration is A equals negative 9 meter per second squared downward. So the meaning of acceleration is 9.8 meter per second. That is the number of acceleration downward. The ball's acceleration is negative 9.8 meter per second squared. This conclusion. This is not example of static equilibrium because the ball is acceleration under the influence of gravity. The net force acting on the ball is not zero, resulting in a changing in velocity. The ball's motion is not balanced and it is not at rest. So like I said, the tension or forces of torques must be at rest, and not mentioning acceleration is a static equilibrium, and it's influence also in the gravity, so that's why it's not static equilibrium. So I hope you guys did understand my explanation, and this is another example of it. Try it in your home or anywhere you are watching this. Try this. This is another example. So that's it. I hope you guys understand my explanation. Thank you.